Okay, first thing I need to do. Unmute myself. Yeah, cool. Okay, hello everyone. Oh, perfectly timed. I couldn't find the web either. Yes. Okay, hello everyone. I think pretty much everyone here, it's a welcome back with a couple of exceptions. Firstly, I apologize slightly for starting slightly late. Ignore that clock, just like last week, it is incorrect. I had some issues finding this room. I've done a few presentations here. It's definitely the first time I've had a room so big. Due to there not being so many people in person, I don't really think that we need me to use the microphone. If at any point during the presentation you thoroughly disagree with that assessment, please let me know. I'll be happy to use it if it's required. But most of the time in life, I am loud enough. Okay. So yes, welcome back. If you're one of the people who it's not a welcome back and you haven't come to the previous sessions, let me just briefly introduce myself. My name is Harry. I've lived here for about 5 years, but before I came here, I completed my master's degree in mathematics, which is really going to be helpful for today. Okay, now we've got 3 hours. We are going to face a similar problem that we faced within the first of our class or lectures together. The scope of this, and we'll talk more specifically about what can be included, but the scope, the description of what can be expected, what they can ask, is so very broad. So I'm not going to be able to cover everything they could be asking on the exam, okay? That would involve me covering all mathematics up until just pre-university level. Okay, we've got a long time, we have not got that long. So I'm going to be focusing us today on good exam tips, methods for solving these, and a couple of little tricks, time savers, mathematical techniques which you might not be used to, so that these can apply to as many different question types as possible. Okay. These are generally going to fall into these categories. The general guidance will be things such as time allocation, the eternal tip of reverse engineering from the answers in a time restricted setting. This is going to be quite quick, I'll be honest. Then we'll look at the required skill. Yes, lots of it is just going to be all mathematics you did up until you left school. But what that includes will vary per country you've been educated in, right? I mean, I teach maths as a full-time job in Hungary. We teach negative exponents and set theory and all these things which, being educated in the UK, I did not learn in school. Okay, I did learn at university, but I want to make sure to cover a particular few topics which might be sort of common school level in here and in India. If you're not aware, that's where a lot of the GMAT process happens. Because both countries generally have quite high mathematical standards. So if there's anything that might have sort of slipped in the gaps in your country, I want to make sure that it's not going to sort of make it past today. That will include the required skills. These extra skills are the ones I just mentioned: time savers, shortcuts, unconventional mathematical techniques. Because to be honest, to sort of get this piece of news out of the way early, this exam is difficult. When I was reading through the practice questions, lots more of them than you would like seem to resemble something that you would see in a maths competition. Okay, so there might, even as we're going through today, be questions which you look at and you just simply haven't got the beginning of an idea of how to start. So these extra skills are going to give you a way to get started on those questions which otherwise you might have no idea how to even get going. And we're going to be ending, though we're going to drop in a few sort of as we're going through with practice questions. So that's enough preamble. Let's get on. So even in a time-pressured environment, my main and most important piece of advice, I put it at number 1 for a reason. Read carefully, okay? If you read the question in 5 seconds, you spend the next minute trying to answer it, and then you realize you misread it to begin with, that minute has been wasted. You might as well have spent 10 to 15 seconds reading the question. You will have saved yourself that minute. Okay, so yeah, I know it's stressful in a timed environment, but please still read carefully. Look for shortcuts, okay? Some of these will be moments of mathematical insight from being familiar with certain things, like certain bracket expansions, recognizing certain forms, and then maybe you can simplify things. You can find a little quick route there. A lot of this stuff is going to fall within that last or penultimate section in those extra techniques. But this also will include things like, well, it can only be one of 2 answers. Instead of going the long route of doing out all the algebra, let's just put in that value. Does it work? Yes or no, etc. So these reverse engineering options which present themselves very nicely in multiple choice exams. You actually have slightly longer per question than you do in the other sections. Okay, we're looking at about 1.5 minutes per question. Okay, we're looking at about 1.5 minutes per question. For the other sections, it's been just under a minute, rather than, you know, a decent amount over a minute, right? Halfway to 2. But this is not without reason. As I've said, some of these questions do get quite difficult. Yes, I've made up a word for number 4, but the natives get to do that. It's unfair, but it's true. Algebraify carefully. Okay, basically the same reasoning applies as the read carefully part at the start. If you get a bad algebraic equation quickly, it's not worth it. Okay, make sure you can justify your operations. Why are these 2 numbers multiplied? Why are they not added? For example. Another thing which I'll go into a little bit more detail with later is once you've got yourself an algebraic equation or even an algebraic expression, put in a couple of values. Have an idea of what you are expecting out. Are you getting out what you expected to? Taking the extra time to check it then is worth it rather than finding out at the end. Okay, I said that first section was going to be nice and quick. Let's look at the required skills. If you were here last year or you took the exam last year without coming to these sessions, we do have some good news. It's simpler than last year. They've taken out some of the more frustrating question types, including the calendar questions. If you're not aware, those were the ones I likes teaching the least last year. If you don't know what I'm talking about, good news, you don't have to. Okay, so actually a lot of these things have been restricted. They've taken out a lot of the a lot of the geometry as well. Okay, so it's actually a smaller pool, a smaller range of questions than it was last year, but don't mistake that for meaning it's not still big. So we're going to break this down into 4 or so sections. We'll go on through each one. So value, order, and factors. So exponents is just another term for powers. As mentioned, some countries cover these in more detail than others. For this reason, particularly negative exponents, so things like 2 to the power of -3, and fractional exponents, for example, 4 to the power of 1/2. I'm not assuming, though I might be wrong, I'm not assuming that you already know what those are, so I'm going to give you a little bit of detail on those in a moment. Factors, multiples, divisibility, and remainders. So one of the particular things that's going to fall under this grouping is highest common factors and lowest common multiples. I'll give you an example in case you've studied these, but maybe not in English. If we're looking at the numbers 15 and 10, the lowest common multiple is 30, the lowest number they both go into, and the highest common factor is 5. Okay, so the highest number which goes into both of them. But with all these topics, including the one I just mentioned, it's not just going to be a matter of I know that, or I can do that when prompted. You will not so directly be prompted. You will have to know, you will have to understand that these techniques, these methods apply. It won't be one question which says find the lowest common multiple and the highest common factor of these two numbers. Okay, it will be a step in the process. It will not be the whole process. Decimals and place value will really just relate to a couple of questions, and they're kind of predictable types. Okay, it will be a matter of writing, for example, 123 as 1 times 100 plus 2 times 10 plus 3 times 1. And of course, we could carry that on to the decimal places as well. But they have a few questions which apply this in a weird way. Okay, you'll have some questions about how many non-zero decimals do we have in this particular number? And those are going to revolve around understanding what the denominator does in a fraction, saying it's a power of 10. And that will again relate to place value. The last one here is the properties of operations. I've written order preservation there, and I have a whole slide on that later, so I'm not going to go into it massively now. The important thing is using some of these order preserving properties to simplify questions which look otherwise not very nice. We've got algebra, equalities, and inequalities. Okay, to be honest, of all the topics today, these are the ones I'm going to be touching upon least. Okay, if there is a word on this board which you're not familiar with, make sure that you are familiar with it by the time it comes to the exam. Okay, algebraic expressions and equations, I can't imagine anyone is getting through school without being familiar with those. Same for linear and quadratic equations. Inequalities probably, but maybe it's been a little while since you studied them. Again, just to sort of make sure you know what I mean. This is things like x plus 5 is less than or equal to 3. So not with an equal sign, but with a less than or a greater than, etc. Functions, the main thing you need to be familiar with functions is the notation and being able to understand when some of these questions are phrased in the language of function. So this is something like f of t with the t in the brackets, and then they tell you t squared plus 5, something like that. Some process you're going through with this number t to get an answer out. We will have one practice question which demonstrates this. Graphing, I honestly will not be mentioning at all. Okay, I do not have time to be going through all of these, and I'm not going to patronize a bunch of, adults. You're probably familiar with graphing. Okay, I will be providing my own tips, particularly for unit conversion, because even the method they talk about in the book is not perfect. I have a little shortcut for you here. Hopefully a tip that will make you go, oh, it's just that easy. Yeah, it could always be that easy. But that's the main one on this page, which I'm going to be going into more detail on. Okay. Very similarly, it's this last point, number 3, rate, work, and mixture problems. I'm already quite familiar with them because they love them in the Hungarian education system. Okay, so if you're Hungarian and here, you're probably a little bit more familiar than most. But we will be doing practice questions with these. I will be demonstrating what's good technique for these rate, work, and mixture problems. Ratio and proportion, again, I'm kind of just assuming you're fine with that. Multiplying things in ratio, scaling things up together. I don't think we need to spend a lot of time on that. Very similar regarding converting decimals, fractions, and percentages. One thing I will mention for this second point, this can be one of those skills that can sort of save you time and help you see shortcuts. Okay, if you know, for example, the decimal representation of 1/8 without looking, that probably means you're going to recognize it and be able to simplify your life a little bit if it comes up. So the main thing that will be useful here is knowing common fractions as percentages, common percentages as decimals, etc. Not going to spend a ton of time focusing on it, but if you have them quick to mind, your life will be simpler as we go through some of these questions. And we've got an other skills sort of section at the end. They're big on the estimation, and it's going to be a real important skill that I have some specific recommendations for in that extra skills section. It's particularly important because this is a non-calculator exam. Who needs estimation when you can shove it in a calculator and it'll tell you the exact answer? But you can't, so you will. Okay. The stats, I only have one specific area of that which I'm going to cover. You should be familiar with what the mean is, the median, the mode, and the range. Those are really common. I teach my year 10s those. I'm not going to be mentioning them a lot today. The one part from the stats topic, which I will absolutely be mentioning it, because to be entirely honest with you, when I was going through the practice questions, I saw one of them demanded that you calculate this by hand. So I thought I would include it. Here I am talking about the standard deviation. It is a measure of spread. I'll leave it at that for the moment, because as I said, it's going to be one of our extra skills. It's going to be one I'm talking about a little bit more directly later. Counting methods essentially talks about combinatorics. So that's combinations and permutations. I'm throwing a couple up for that as well. Regarding the required skills section, because again, it's something which is taught sort of through Hungarian schools, but it's not necessarily the same for every other country. Sequences and series, there won't be a ton on, but I will give you some guidance, because to be honest, the only questions they seem to ask about sequences and series are surprisingly difficult. So I've particularly got one practice question, which I will guide us through when we get there. Okay. So let's look at these more uncommon skills, which maybe you got through your school experience without having seen. You'll need to know absolute value signs, and you'll need to know number sets. Okay? These absolute value signs essentially mean distance from 0. So the absolute value of 3 and the absolute value of -3 are the same. They're both 3. You need to also be able to answer questions such as the absolute value of 2x plus 1 equals 1. For those equations, you take both possible options. If the absolute value of 2x plus 1 is 1, we have two options. Either 2x plus 1 is 1, or 2x plus 1 is -1, sorry. Those equations you can just solve as normal. I'm not going to go into more detail. But as soon as you see these absolute value signs, whatever is in those signs equals positive, the number they gave you, or whatever's in those signs equals negative, the answer they gave you. Okay, but I would be fully understanding if that's just not something that's been focused upon in your previous education. Speaking of, let's talk about number sets. For me in the UK, they weren't something that was mentioned until I was a little bit older. Don't let that put you off. There's nothing particularly complicated about them. Hungary agrees, which is why I teach them to my year 9 students. You'll be fine, but you need to know what they are. The integers are whole numbers. So notably, these include negative numbers as well. So -4 belongs to the integers, 0 belongs to the integers, 2.5 does not. Okay, these are just your whole numbers. And again, if the language you are educated in mathematically was not English, absolutely understandable. But you need to be familiar with these terms, otherwise you won't even understand the questions. Okay, so you need to know what an integer is. A natural number is essentially a positive integer. The quickest way to think about it is counting numbers, right? If you count, I have 1, 2, 3, 4, 5 something, you're never going to count -5 pence, right? You're never going to count 2.5. Okay, these are just counting numbers. The real numbers are not every number, but this exam does not include complex numbers. So as far as you are concerned, the last number set you need to know is the real numbers, every number you've ever heard of, as long as you have not heard of I. Okay. So these are the negative and fractional exponents I was mentioning at the beginning. Let me, in fact, answer those two questions I gave at the beginning using these as reference. I said 2 to the power of -3. So all that means is 1 over 2 to the power of 3. So 2 to the power of -3 is 1 over 8. Honestly, that's all there is to it regarding the negative exponents. I will also recommend when it comes to these power combination rules, which, by the way, if you're copying stuff down, you can just Google these. They won't change by the time you get home. Is that when it comes to these power combination rules, you frequently don't even have to interpret what a negative power is. Close your eyes, trust the maths, and just use the negative number in the same way you would use the positive number. These negative powers are defined this way for a reason. Just use the negative number using the power rules. Maybe at the end, you'll have to actually tell me what 2 to the power of -3 is. But for most of the question, you can just use the power rules with n or m as a negative number, for example. Absolutely not a problem. That will still all work fine. The other one I said at the beginning was 4 to the power of a half. And we can see from this second one here that that is the same as the square root of 4. So that is 2. Okay, so for example, we can also have 8 to the power of a third. 8 to the power of a third is the cube root. So the third root of 8, which is 2. Again, you don't always have to interpret these. Just use the power combination rules with trust. The number will come out correctly, okay? Though there will be certain times when you do need to interpret the answer at the end. But a lot of the time you can just use those rules blindly. Okay, and nice and briefly, if you multiply two numbers, notice they both have to be x. If it's let's say 3 to the power of 3 times 5 to the power of 2, there is no combination rule. For all of these, you need the number at the bottom to be the same. So, for example, 3 to the power of 2 times 3 to the power of 3 is 3 to the power of 5. I know, because my students tell me all the time that writing algebraic rules like this often makes things less clear rather than more clear. Put in some values, it will make immediate sense. Okay, so this is what I was talking about regarding the standard deviation. This is a stats topic. So the mean, the sort of most common average, will tell you where the center of your data is. But many sets of data which have the same center are very different in other ways. For example, I could stand here and I could say 0, 10, 0, 10, 0, 10 repeatedly, and we understand that the average is 5. I could also sit here saying 5 repeatedly, and of course the average will also be 5. But there is something significantly different about those two data sets, especially if you want to start drawing conclusions. So we have this idea called the standard deviation. It just tells you what is the spread. If it's nice and small, all your data points are brought together, crunched together quite nicely. If it's a much wider range, then of course your data is more spread out. I'm going to explain not just these steps, which you can already see written on the board. I want to explain the idea behind them. Why on earth are we doing these steps to calculate some kind of spread? So we find the mean of the data, okay, fine. Then we look at the distance between each of these points, each of these individual data points, and that mean. However, for some of these, let's say a data point is 1 below the mean, we'll get an answer of -1. But if it's 1 point above the mean, we'll get an answer of +1. But I'm sure intuitively you understand we don't care which side we're on. What matters much more is sort of how far away we are. So we can't just add together all those differences, because those pluses and those minuses, we don't want them to just cancel out, right? Otherwise, both of those data sets, those zeros and those tens, and those fives would both give 0, because we get +5, -5, you add them together, useless. This is why we have step 3. We square the differences. Okay, you square the differences. Then we find the average of those different squares, and we square root the final answer. Specifically, we take the positive root. That seems like a really intimidating list of steps for me to give you, particularly in the context of a non-calculator exam. You can forget about these last 3, broadly. Okay? Because in practice, you will get questions about which of these data sets, etc., has the largest standard deviation. You're not expected to go the whole entire way through the calculation and then spit a number out at the end. By the time you get to the end of step 2, realistically, you already know which one has the biggest standard deviation. Okay, if you can see a list of +7s and -7s, you can just ignore that sign and you can go, okay, which list has the bigger numbers, ignoring that sign, and write that answer. Reminder, you are only going to have 1.5 minutes per question. So step 1 and step 2 of just finding the mean, finding the difference between each of those data points and said mean. Maybe that's a minute and you've got 30 seconds to spare, but it's already going to be enough work. This is particularly going to work and work nicely because those steps I've just crossed out are what we call order preserving. By that, I mean, if your numbers were in a certain order before, you can multiply them by 5. You can divide them by 16. You can add 32. The order will not change, right? Whatever order they were in before, they are still in now. Okay. We'll be coming back to that order preservation stuff. I think I put my slide on it in the extra skills section. So, again, I come back with a slightly different version of the same made-up word. This is one of the most underrated skills in mathematics. I have had so many of my students who are top of the class, amazing mathematicians, and then you give them a question which is only in words, and they have no idea how to get started, okay? Actually, relatively few of these questions start you off with an explicit equation. It will be up to you to take the information given to you in the question and turn it into algebra, turn it into something you can solve. So I have a few tips here. Firstly, as I mentioned at the beginning, choose your operations carefully. Right? Things like multiplication tend to apply to areas. Tend to apply to anything which you could put on a grid, for example. I call, with my students, I call it panic maths. When students see, oh, there's two numbers there, grab, push together, make new number come out. Again, even in a time limited environment, it's not worth the extra time you're going to waste. Choose your operations carefully. Tip number 2 is a little bit more specific. Look for quantities which can be expressed in 2 different ways. The most common of these will be as a total and as a sum of parts. For example, if you're given enough information, can you write out between density and weight the amount of wood, for example? If you can do that for all of your different terms, make sure you are adding together similar quantities, okay? If you're adding an amount of wood, it should be to another amount of wood. If you're starting to add terms which don't really relate to the same thing, your equation is not going to be correct. And this last point is one, again, that I mentioned it briefly in the intro. Once you've arrived at your equations, check a few specific values. Check a few specific values, specifically where you know what you should be getting out, so that you can either get it and be confident or not get it and quickly reassess what went wrong. Where did you leave your expectations behind? We're going to have a few questions in the practice section which specifically align to this algebraification. But it is one of them, honestly, one of the skills which applies to nearly every one of the questions, okay? So please do not underestimate just how powerful this skill is. So we've got compound interest as well. Simple interest is also involved in the exam. The only reason I haven't mentioned it here is because it's essentially percentage work. Okay, I don't think you need so much guidance on this. But on the compound interest, maybe you do. Okay. So even with me having listed the meaning of what each variable is, I still have a next slide where we're going to actually show what it looks like to use this. Okay. But I've also added a little note at the bottom that occasionally they will specifically ask you for the interest. So not the current value now, how much interest has been earned. You don't need a separate formula, really. You just need to take off the initial investment after using this one. Okay. So let's look this is like in action. Here, I'm writing the question, honestly, nearly exactly the same as it is phrased in the question, in the practice questions. This is what you should be writing, and this is what you should be writing if they give you a question like this. And again, okay, here they are giving you some specific values, but the whole thing is words. They're not giving you an equation. $10,000 is invested for a year, compounding every 6 months, and interest rate of 10%. What's the value of this investment after a year passes? So, when it says compounding every 6 months, look back at this last slide. N is the number of compounding periods each year, which is, surprise, surprise, why N equals 2 on this next slide. The initial investment is P. One thing I will write though, or one thing I will draw your attention to. You will see different versions of this formula. You might recognize one where instead of that right-hand term being R over N, it is R over 100N. The only difference here is you need to write the interest rate as a decimal to begin with. So if the question says it's an interest rate of 10%, notice it's 0.1 on top of that fraction, not 10. Otherwise, you're going to get some absolutely crazy money back guarantee where your money multiplies by 6. If you find it, let me know. Otherwise, be nice and careful to use the interest rate in decimal form. Okay, and from here, hopefully you can see those steps. The last one I haven't mentioned is that T is 1, because T is simply the number of years. So from here, you simplify as you go. What's in those brackets becomes 1.05. And you just compute at this point. Okay, but you do need to be familiar. You do need to be able to use this formula. Though a really sort of keen observer might ask me a very reasonable question, knowing that this is a mental maths exam. We don't have a calculator. So how am I, particularly with respect to these compound interest questions, meant to square 1.05 in my head? Okay, when I'm preparing these presentations, I have a calculator. Not a problem. I don't need to do my maths qualifications. I already have them. But how's this going to work when it comes to exam time? Okay. I will circle back to that question. I forget slightly the order of the slides. That's our first of our extra skills. I'll go into how you're meant to be doing that in your head. But let me mention these last required skills before I do so. This is the combinatorics I was talking about earlier. Okay, this is the study of possible groupings. For example, if you have 3 people, you can make 6 groups of 2. Okay, but we're specifically talking about groupings without an order being important. So we're here talking about combinations. There will also be questions where the order matters. For those questions, you're going to be using permutations, okay? For most of these, it's just going to be formula work, okay? If you're not familiar with these terms, please look them up, have a little bit of research in your own time. But aside from using the formula for combinations and using the formula for permutations, you will also have some expectation of being able to freestyle. With that, I mean they will give you questions which are not a straight usage of the formula. They will require you to use the ideas which fall within this topic. Specifically, I'm going to give you this piece of advice here. If you have a question like this, where it's not just a strict application of the formula, your best train of thought to take is to think about the number of options at each step. And you will end up multiplying those together. We have some practice questions here. Here is one of the more standard, just use the formula type of questions. Okay, if each of the 12 teams competing in a tournament must play every other team, how many total matches are required? Before you even go into trying to answer one of these questions, you need to ask yourself an important question. Does the order matter? Because before you've answered that question, you don't even know which formula you're going to be grabbing. Okay, so make sure you're answering that really carefully. In this instance, the order absolutely does not matter. Okay, if I say that Man United played Tottenham yesterday, obviously Tottenham also played Man United. That order does not matter. So here, I don't know if you're familiar with this notation, but all it is notation that means this formula next to it. Though if you're not familiar with it, again, I really advise you have a proper look before exam day. But from here, it's just number plugging in. And simplification. However, for those people unaware, I will briefly highlight this particularly loud 12. Okay, anytime I introduce exclamation marks as mathematical notation to my students, they look at me like I've done something wrong. This is shorthand for 12 times 11 times 10 times 9, etc. Just going all the way down. It's also why these brackets on the bottom are deathly important. Lots of my students will try and write 12 factorial minus 2 factorial, but that's not right. You do what's in the brackets first. Now that you know what those exclamation marks mean, hopefully my simplification in the third step makes a little bit more sense. Because every number 10 and after will appear on the top and the bottom of the fraction. They're all multiplied, so you can just simplify from there. Every number less than 10 has gone off the top, and the entirety of that 10 factorial has gone from the bottom. So these simplifications, particularly in a mental maths exam, are crucial. Just so you're aware, even 5 factorial is 120. You start going 6 or higher, you're going to end up writing 10-digit numbers. That's never happening in a mental maths exam, let alone in 1.5 minutes. So these simplification tips will be crucial. Let's look at one of the more unconventional ones. It's not simply we have X people and we're trying to make groups or orders of Y people. Here you're going to need the ideas rather than simply the formulas. A group of 3 men and 3 women must stand in a line in which the line starts with a woman and alternates between women and men. How many different lines are possible? Okay, I've typed this one up, but it's an exact copy from the NMAT practice. When I say think about how many options you have at each step, I'll take you through that thought process now. We have 3 options for who can stand at the front. Any of the 3 women. We have 3 options for who can stand second. Any of the 3 men. But by the time we get to the 3rd person, we only have 2 options. Because we don't know which woman is standing at the front, but one of them is. So we only have 2 options remaining. Once you carry that train of logic through, you'll get 3 times 3 times 2 times 2 times 1 times 1. This will get you to the correct answer of 36 possible options. But that's the process I want you taking yourselves through. That's the process I want you taking yourselves through. Okay, cool. So, here we have, honestly, I'm expecting a lot more from here on out to be new to you. Okay, these are tricks I use in setting questions for my students, tricks I use in seeing shortcuts myself. But even as I was going through the exam, I saw plenty of these questions where I can see the shortcut, I can see the little trick they're using, but if you can't, you'll get what could be a 20-second question could easily turn into one you have to abandon because you can't spend 5 minutes on it. I'm going to be starting with what I was talking about earlier, using algebra for mental maths. So, okay, in the last example, I was talking about squaring 1.05. But here I've taken the option to square 2.4. We've got two main techniques I'm suggesting to you. And the first technique is really why I'm calling this section Algebra for Mental Maths. If you can expand x plus 1 all squared as a bracket, you can do the same thing when both of them are numbers. People don't frequently do it, but there are plenty of times it is useful. So it will be the first term squared plus 2 times the product of the numbers plus that last term squared. I've also drawn this box next to it because mathematically it comes out to be equivalent to the grid method. If you're aware of the grid method, it's something they really focus on in the UK, but the same idea comes out. That top right box is 2 squared. The top left and the bottom right box are both 2 times 0.4. So overall, we have 2 times 0.8. And that last box at the bottom is 0.4 times 0.4. Adding these all together will give you the square you're looking for. And it's going to be a lot more approachable than just sort of staring at 2.4 until it squares itself. Okay. So this is a really useful sort of time, not only just time saving, but honestly, lots of these decimals are very difficult to square full stop, even without the time concerns. Another recommendation I can give you is write them as fractions first. Frequently, the fractions are easier to deal with. Okay? So, for example, here, just focusing on that 0.4 squared, because I would fully understand if you are unsure, like is 0.4 times 0.4 0.16? Is it 0.016? Which is it? So here I make a recommendation. Write it as a simple fraction. This is where those sort of digit and place value skills are going to come in useful. Because, yes, I could write this as 2/5, which is the simpler version of 4/10. But then after I do all this, I'm going to have to do more work to put it back into a decimal. If you just leave it as over a power of 10, I don't care that it can be simplified. I'm just going to go ahead anyway. It will be much easier to convert back into decimals at the end. So here, I'm just squaring top and bottom. And with this method, you can immediately see that I got the number of zeros, right? You can immediately see, okay, that's 0.16. That's not 0.016 or anything like that. You can also just do this from the beginning, okay, without sort of splitting it into decimals, doing all this. A slight warning if you are going to do that, though. It's not much easier to square 24 in your head than any of these decimals. So sometimes you've got to avoid squaring the low numbers and the high numbers. But these techniques are all available to you when it comes to the mental math side of things. Also, I haven't included an example, but if you have a decimal like 2.9, it might be easier to break it up into 3 minus 0.1 and sort of simplify it from there, rather than trying to break it down into 2 and 0.9. Just like when you multiply by 9, really. Okay, here's my cheat sheet for unit conversion. Okay. This is something which most people think is easier than it is. Because you'll get two measurements and you'll know that there are 1,000 millimeters in a meter, for example. But then you'll sit there thinking to yourself, like, okay, but does that mean I need to multiply by 1,000, or does that mean I need to divide by 1,000? And if you don't have a good reasoned answer to that question, what you instead have is a 50-50 chance of getting it right. So if you haven't seen it before, this is the easiest, most reliable. The steps from left to right are as simple as they appear, and it works really nicely. Okay, you basically need to treat your units like variables. I know it sounds a little bit weird. Let me give you further explanation. Hopefully, you fully understand that 1 kilometer is 1,000 meters. It's perhaps a little less obvious, but still understandable, that 3,600 seconds is an hour. When I say that you treat them like a variable, you can substitute kilometers for 1,000 meters, and you can substitute hours for 3,600 seconds. Exactly as if it was a substitution in like a simultaneous equation or something like that. You've got to be nice and careful though. If kilometers were on the top of the fraction to begin with, 1,000 meters should be on top of the fraction now. No allowing anything to sort of jump the fraction. From there, you can just split off the numbers in the fraction from the units, and simplify the numbers as required. Okay. And this means you don't have to sort of work out a different method for any different measurements, units, etc. This is actually a small section of something called dimensional analysis, but I have to know that you don't. It's very useful. From the time I learned it, I will not be doing anything else ever again. Same with this unit combination. Again, you'll reach a similar point. You'll be given, let's say, a number of miles per hour and a number of miles per gallon. And then the question you have to sit there asking yourself is, do I multiply them? Do I divide them? Am I adding them? Like, what's going on? How do I combine these two numbers? The trick is to look at the units. Whatever you do with the units to get the new unit is what you should be doing with the numbers as well. So, for example, here, we can see that miles per hour divided by miles per gallon. Once you use the classic fraction trick of flipping the bottom fraction and multiplying it, very quickly simplifies. Those m's cancel out and you want them to. And then this tells you that doing miles per hour divided by miles per gallon gives you gallons per hour. You can look at that unit essentially as a guide for what you should be doing with the numbers. This specific part is, okay, I haven't copied out the question, but it was essentially a boat goes 60 miles an hour at 5 miles per gallon. What is the sort of gallons per hour for this vehicle? If you're not familiar with this idea, there's a good chance that you just combine those numbers wrong. So the key to how to combine those numbers is really within the unit itself. This is one of those questions. Okay, let's ignore for a moment everything on the board apart from that top question. If x to the power of minus 3 is a half, what's the value of x to the 6? This is one of those questions which you might be reading through and you'll go, oh, have I mistakenly entered a maths competition? How am I meant to do that? So I thought I'd let you know. No, you don't have to go the whole way of working out what x is and then afterwards at the end raising it to the power of 6, especially in the context of a minute and a half. So what I'm going to highlight is some of those power rules which I had in the earlier slide. You can just kind of use directly as they are, with specific and careful choices of n and m in this case. So we have x to the minus 3. We want x to the 6. So here I can see that if I pick n equals minus 3 and I pick m equals minus 2, that left-hand term will give me x to the 6 like the question would like us to do. And this is important and this is useful because you don't just have to substitute x equals something. You can do it for expressions containing x as well. So we can substitute the whole of x to the minus 3, knowing that it's a half, all at once, and then just simplify 1 over 2 to the power of minus 2. As we spoke about, the minus sign means sort of flip it. It means 1 over. And then you square 2 as normal to get 4. You do not have to go through the whole process of doing the cube root of 2 and then doing it to the power of 6. If you're clever with the formulas, you can substitute it in as you already have it. You don't need to do sort of work to get there. Also, if you use this technique, you look like a wizard. There's going to be a few times this applies, but it's just a really useful technique if you're not already familiar with it. Okay. Again, I wanted to sort of make a section on any questions that as I was reading through, I would not blame people if they had no idea how to even get started. So, for the following pair of simultaneous equations, find the value x, y. Now, if you don't know a specific technique or a specific shortcut, you're going to have to go through the entire process of working out x and y, solving the higher order simultaneous equation. It's possible. I can teach you how to go through the substitution steps, to do the rearranging. It's possible, but it's long. Okay, it's really long. So this and the one I'm going to show you next are ways which you can cut it in half or more by having a bit of mathematical insight. Specifically here, we're going to take advantage of being familiar with the form of x plus y all squared. I know that if I square that top equation, the only term which is not going to appear in both is that central 2xy term. Right, the x squared will be there, great. The y squared will be there, great. And that will allow us to isolate the value of the middle term. Okay, so I've done just that. I've squared both sides of that first equation. Be aware whenever you're doing something like this to both sides, you need to pretend that everything's in invisible brackets. No squaring x and then squaring y, you square it all together. And then suddenly this equation looks very much like our second one. And just by comparing across them, we can see that 2xy is minus 4. Okay, because if you include it, the answer is 9. If you don't include it, the answer is 15. Okay, the difference between those numbers is 6, but apparently I was writing a lot. But the idea is the same, right? You find out that 2xy is minus 6, so xy is minus 3. You can see how this can shortcut your time. Trying to go through all this, working out x, y, just to multiply them together at the end is not going to be worth it. We have a similar question here, where they're instead asking you to find the average of the two numbers. Again, if you look at this question and you had no idea even where to get started, I would not blame you. So let me give you some tips. If you can combine these equations together in any possible way, which gives you the same number of x's and gives you the same number of y's, you can divide through by whatever you want afterwards, right? Here, okay, it's a factors question I made up. So it's nice and simple. Once we add these two together, we get 2x plus 2y equals 18. In general, that would be bad simultaneous equation solving technique, because you've got to go through those steps and eliminate one variable, not give yourself equal amounts of both. But here, that's exactly what will be useful. From here, you can just divide that equation through by 4, and the average is 4.5. Again, you don't need to go the whole way through, though, to be honest, this one would be much easier to just get x and y and then sort of find the average of them afterwards. It will still be much slower than doing something like this. So keep an eye out, particularly in these simultaneous equation questions. I haven't got a slide on it, but whilst we're talking about these simultaneous equation questions, let me say they love to put them in word form. Okay, so when we're talking about the algebraification, etc., lots of questions are essentially going to come out to be simultaneous equations. So you need to identify that when that's the case. For example, if you read a question and you get one equation written down because you've been practicing your algebra creation, don't necessarily stop there. Frequently, there will be two equations hidden, and it's essentially just a simultaneous equations question. But do watch out for them. Okay. We got a little stop on the order preserving operations. I mentioned the key idea a little moment ago, but it was kind of brief, and sometimes it really helps to put some numbers, put something a bit more substantial behind just giving you the idea. The 4 standard operations are all order preserving. Just to be clear, what I mean by that is if you have the numbers 2, 3, 4, 5, for example, obviously already in order, you can multiply those numbers by whatever you want. The order will stay the same as long as that number you multiplied them by is not negative. You can add 7 to all of them. The order will not change. These order preserving operations are useful because you will be given questions like this. Which of these values is the biggest? And you don't have a calculator to just sort of put them in and copy out the decimal. So knowing which operation to use to make your life simpler will be a matter of mathematical insight. But here it's definitely going to be squaring. Notice this second part I wrote is that squaring and square rooting are both also order preserving as long as we stay on the same side of 0. Okay, as long as we stay on the same side of 0. Here, squaring is the best order preserving operation to choose, because what's the worst part of this question? It's the square roots, right? How are we going to get rid of those other than squaring them? So we go through. Notice I'm just squaring the term on the left. 4 becomes 16. And for all of the numbers on the right, the square root sign just gets cancelled out. And then at the end, you've got some nice 2-digit multiplication. Okay, way easier to manage than trying to estimate what the decimals of these. Nah, that's not going to happen. So use these order preserving operations. When it comes to fractions, the best thing to do is multiply through by some big common factor, which is going to turn them all into integers. But it's the same idea, right? Do something to them which you know is not going to change that order. Okay. Okay, I tell you what, I know it's a little bit before 5. However, I know the flow of this presentation. I've already been dumping enough techniques and other extra skills on you. We have about 1, 2, 3, 4, 5, 6. We have about 6 more of those to do. And then we've just got the practice questions. The practice questions will be sort of applying this stuff, but I think it will be less taxing on your brains because it will be less of me dumping a lot of information on you. So, suspecting strongly that no one will object, I suggest we take our break now. Ignore that clock, it is 10:02. Okay, and then we will return at 20 past to talk through the last of these tips and to talk through the practice questions, okay? We've got a decent amount of these practice questions, but if you've been to the prior presentations, they're actually not going to take as long per question as, say, the reading comprehension ones from last week. So I also say let's take a slightly early break because actually I suspect we'll be finished before 7. Okay, thank you very much. Okay. We have a few people, fewer than we did for the first half, but the people that have been to the prior sections will tell you that is not unfortunately rare. So, let's pick up from where we were. Okay. So, look, continuing through the questions, which when I was looking at them, if you were to sort of not know, I would not blame you. So let's talk about questions like this one here. If a discount of 40% is applied after a discount of 30% has already been applied, what's the total discount on the original price? And no, it's not going to be 70%. Right? If you do 50% off and you do 50% off again, you're actually 75% off. Don't get me wrong, not a bad discount, definitely not an 100% discount. So let's look at the best way to honestly do these questions quite quickly. So when you're talking about it being 40% off, you'll notice I've done this sort of 1 minus 40% business, because if it's 40% off, it's 60% of the original price. If it's 30% off, it's indeed 70% of the original price. Once you get to this second step, it's just a matter of multiplying the decimals, maybe using that grid method or that algebra for mental math section I was talking about earlier. Because if you write this as 6 over 10 and 7 over 10, getting 42 over 100, i.e. 0.42, nice and simple. You then have to do the same thing at the end, kind of in that reverse direction. If you're paying 42% of the original price, that is 58% off. Okay, so if you get a question about doing these repeated discounts, you can use this method. You will also get questions occasionally where you're not asked, okay, what's the full discount? You're given the final price and you are asked to find what the price was originally. All of this will still work, but at the end of it, you just write 0.42x equals the discounted price and you solve for x, it's fine. Okay, but any question involving these discounts on discounts, this method is going to apply to. It's a quick one. So we're now going to talk about these mixture, work rate, and other related problems. These are problems which are, in my experience, more common in Hungary than they are in other countries. But let's start with the mixtures. Okay, so before I go into this technique and explain sort of what we're going to do, let me give you a way of thinking about it. And I'm going to give you the idea of weighted averages. I use these in school all the time, not because the students need to know them, but because I need to calculate their grades. Okay, so yeah, this is our usual average form. But we can split it up and we can just write it as like, oh, that's 50% X and 50% Y. That's a normal average. When I say a weighted average, it's something like one of these two below it. It's not a 50-50 split of X and Y both making the same amount of contribution. Maybe it's something like 70% X and 30% Y. Okay. Then we can have a weighted average like this. I'm going to give you one question where this applies directly and works wonderfully. And then I'm going to give you another question which looks really similar, but it's not precisely the same. Mainly because the two numbers, like let's say 0.7 and 0.3, are not necessarily going to add to 100 or 1. Okay, but the technique will be very similar. But let's just first show you the sort of most straightforward it can get, the most straight ahead version. Again, this is a question from the exam. If 6 kilograms of nuts, which cost $1.20, are mixed with 2 kilograms of nuts, which cost $1.60, what's the value per kilogram of the resulting mixture? So this is a perfect example of when you can use that weighted average. Okay, 75% of that mixture will be the sort of first kind. 25% will be the second kind. So you can just do this weighted average immediately, take your safe time and invest it into another question type. Okay. We'll then move on to one which sort of looks similar, and I want that to be the case, but I will draw your attention to the fact that we are technically doing something a little bit different. How many liters of a solution, which is 15% salt, will be required to make 5 liters of 8% salt solution into a 10% solution? So notice that the left-hand side of my equation I've written down looks very similar to the last one. Again, it's not a true weighted average because spoilers, 0.15 plus 0.08 is not 1. What we are really doing here is adding together expressions of salt amount, right? 0.15 times n is the amount of salt we have in n liters of a 15% solution. Notice it is very common to make the variable what the question is asking for. Okay, because you know that once you get to the end, you want your n equals whatever, x equals whatever to really answer the question. So that first term is the amount of salt in n liters of 15% solution. That second term is the amount of salt in 8% of 5 liters, in 5 liters of 8% solution, sorry. Notice here they are like terms, they are amounts of salt, so we're just adding them together. And then on that right-hand side is a really similar expression, but now the total volume of liquid, the total amount of liquid is n plus 5, and make sure to put that in brackets because it's that whole expression which is the total amount. Not just the n, not just the 5. They both need to be multiplied by 0.1. If you can get this equation down on paper, it's not too bad to solve. The difficulty is getting it on paper to begin with. Yeah, and then I've gone through all the steps. I'm not going to highlight step by step what we should be doing here. The only thing which might be confusing is that between that first line and that second line, I multiplied through by a clean 100 to get rid of all those annoying decimals. And then you will get the answer of 2 liters. So let's talk about work rates as well. Again, in my experience, a very common question type in Hungary, not necessarily that common for the rest of the world. So for these work rate questions, we're going to think about the individual unit done per work time, which is why all of these sort of focus on a 1/over. Okay, so if you're getting sort of our work done, we do that as 1 over r. We'll then add these fractions together, but that won't just give us our total time. That will give us 1 over our total time, so we will need to sort of flip it at the end as well. But let's look at what that looks like in practice. Again, straight from the book. One machine takes 4 hours to make 1,000 bolts, and a second machine takes 5 hours to also make 1,000 bolts. If they work together, how long will it take them to create 1,000 bolts? So that means there will sort of, the first fraction is representing that it will do a quarter of the work in 1 hour. That second fraction is representing that the second machine will do a fifth of that work in 1 hour. And from there, it's just a nice sort of simple fraction addition. Okay, we'll get 9 over 20 because 1 is 4 over 20 and 1 is 5 over 20. But do not write 9 over 20 as your final answer. You still need to invert it. So actually the final answer will be 20 over 9. So 2.22 and then as many 2's as you have the penning for. Okay. But this will be sort of the simplest the questions can be, where it's just an application of the method, an application of the formula. As with, frankly, many/any of these questions, they can also change what information they're giving you, i.e., normally they will give you an output, and it's up to you to reverse engineer the input. A question like this: Art and Rita, when working together, take 4 hours to complete a task. So notice they're giving you the right-hand side of the equals, and they're expecting you to complete the left-hand side of the equals. Art alone takes 6 hours to complete it. How long would it take Rita to complete it on her own? So notice my formula, sorry, my answer starts in a very similar place, but it's that S now which I'm trying to find. So I take 1 over 6 from both sides. I do some nice simple fraction work. A quarter minus a sixth is a 12th. And then again, I do not forget to invert my answer at the end. Okay. Apparently, Rita is not a particularly fast worker. Okay. So now I'm going to show us a selection of practice questions. Okay, just like with the rest of the tips I've given you in the sort of period up until this point, there is an element of selection bias, okay? I can show you practice questions which are fairly simple algebra from word problems, etc. But I want you to benefit from this session. The other side of that is if you see some really concerning questions, know that that's why they were highlighted, okay? They're not all going to be that bad. I'm going to give you a second to look at this one with a slight hint that the main reason I'm highlighting it is because there's a massive shortcut. Any ideas? Maybe if you don't have any ideas, that's okay. We can use it to talk about some of the answer elimination stuff. The first bracket is positive. The second bracket is positive. The third bracket is positive. The fourth bracket is positive. We can get rid of the top two answers immediately, right? I've never added together four positive numbers and got either 0 or a negative number. Those broad ideas of what we call real analysis, we don't need to get into what that is, but it's that sort of logical process I just took you through. We're not adding together four positive numbers and getting a negative number or 0. So we can just simplify and having a mind, okay, I know it's not that easy to train, but having a mind for those sorts of logical observations and simplifications will be a massive time-saving method. I'll ask one last time before I give the game away. Anyone see the shortcut here?
Yeah. We can remove the brackets.
Yeah, absolutely. And what's the advantage of removing the brackets?
We can just cross out the plus and minus numbers.
Yeah, so you can go through these and I can say, okay, the first bracket is a 6. The second bracket is a 12th. The third bracket is a 20th. The fourth bracket is the 30th. And then you can add them all together and suddenly you're over time. What was highlighted is absolutely correct. These are all just addition. So those brackets make not a lick of difference. As soon as you remove them, that minus a third and that plus a third, gone. That minus a quarter, that plus a quarter, gone. The only two terms which remain are a half minus a sixth, which is a third. Okay? That's just become a lot quicker. So I know I say read carefully, but that also applies to take that extra 30 seconds to see if there's a shortcut. They love putting the shortcuts in there. If you can find them, it's going to turn a 2-minute question into a 20-second question. By the way, I'm sorry if you were here for the previous presentations. You'll notice that they've gone from nice online screenshots to dodgy photos taken from my phone. I apologize, but with this new change in the exam syllabus, I only have a paper copy. So it is what it is. I hope it's still readable. So if a third plus a quarter plus a fifth plus a sixth equals r times a ninth plus a 12th plus a 15th plus an 18th, then r equals which of these options? Before you even start thinking about which of these could be plausible, you need to have your pattern recognition brain on. Right? We can see that every fraction on the left-hand side is just sort of replicated by a fraction on the right-hand side, which is a factor of 3 smaller. So instead of going through all the annoyance of adding together these fractions, etc., to me, there's two answers I would be checking, and I would be checking them manually, not trying to go through all the algebra. Is it A, a third, or C, 3? Pick some specific values, shove them in there, okay? If R is a third, then that right-hand side is going to become an 18th plus a 32nd plus a 45th. Oh no, we've sort of gone in the wrong direction, right? We want them to be getting 3 times bigger, not 3 times smaller. So you could hopefully see that the answer is C. It will become 3 over 9 plus 3 over 12 plus 3 over 15. All those fractions simplify nicely. So in questions like these, especially when you're looking through the answer, the available answers, and you realize it could realistically only be 1 or 2 of them, just try those 1 or 2. It's going to save you so much time than trying to dive through the algebra or just fraction simplification, etc. This is another question where if you read it through and you've not seen anything similar to this before, I wouldn't blame you for not even knowing how to get started. I didn't include this one as a specific extra skills section, but it effectively falls under the same ideas. If, let's say, if one of these is always the biggest, they're not going to make a question where D is bigger for some selection of X and Y, and then E is bigger for the rest, right? So if the ordering of these is going to be the same, regardless of which values of X, Y, and Z you choose, make your life easy. Pick the 3 easiest numbers which go into that gap. 2, 3, 4. I always tell my students you do not get extra points in mathematics for making your life more difficult. Yes, you could choose X equals 100, Y equals 103, and Z equals 502, but why would you do that? Make your life simple. At this point, you just put in the values. One of the numbers will indeed be the biggest. It will not depend on your choice. Otherwise, the question is frankly rubbish. Okay, so pick the values that make your life easier. E will indeed always be the biggest here. Who's seen questions like these before? Again, in my experience, they're more common in Hungary than they are, for example, especially in the UK. But that also might be down to the difference in time between me being in a school and me teaching one. So in a set of 24 cards, each card is numbered with a different positive integer. Again, you do need to know what that word means. If you're not sort of familiar with what that term integer means, okay, you can probably make an educated guess in this instance, but in other questions, it might not be so clear. Okay, each card is numbered with a different positive integer from 1 to 24. One card will be drawn at random from the set. What is the probability that the card drawn will have either a number which is divisible by both 2 and 3, or a number which is divisible by 7? Okay. The main reason that I've highlighted this one, is it's using a small result from sort of prime numbers and factorization and divisibility properties, but they're not telling you that. Which numbers are divisible by both 2 and 3?
6, 12, 18, 24.
Exactly. If it's divisible by 2 and 3, it's divisible by 6. Okay. So once you realize that, you realize, oh, I don't have so many numbers to check. Okay, I'm gonna have what? Let's go through the multiples of 7 first. I'm gonna have 7, 14, and 21. Let's go through the multiples of 6. I'm gonna have 6, 12, 18, and 24. Making sure that I'm not double counting. No number appears in both lists. And the answer is C, 7 out of 24. But if you don't quickly look at that and recognize, oh, they're saying multiples of 2 and 3, but I know that those are just multiples of 6, you might have a much longer time going through and going, oh, 8, is that, yeah, that's a multiple of 2, but it's not a multiple of 3, and you'll have to check every one. If you recognize nice and quickly that numbers which are divisible by both 2 and 3 will also be divisible by 6, your computation time has gone down quite massively. So it won't always be some direct trick or something like that. It will just be you recognizing what that means. I highlighted this one as one of the place value questions because I didn't want to highlight them that much. Because frankly, we've got more difficult ones to deal with. But if you have a question like this and they're asking you to think of or convert series of fractions into decimals, into a percent. The easiest way to do this quickly is to multiply up both fractions until they're over 100. Firstly, it means you'll be able to add them together in the usual fraction-like way. Secondly, whatever number lands on top is the percentage. So indeed, x over 50 is 2x over 100. X over 25 is 4x over 100. 4 plus 2 is 6. Okay. Not the hardest skill I'm going to highlight today, but it's worth doing so. As soon as you see people, giving you fractions and asking for percentages, make sure that everything is over 100. It will make, over 100, it will make your life simpler. Okay, perhaps back to one of the slightly blurrier ones. Bouquets are to be made using white tulips and red tulips. The ratio of white tulips to red tulips is to be the same in each bouquet. If there are 15 white tulips and 85 red tulips available for bouquets, what is the greatest number of bouquets that can be made using all the tulips available? I'll give you a moment to think. The real benefit of doing these questions together is to give you time to think. Yeah, I'm sorry. Any blurriness I could see on my laptop screen has only been increased by the time you blow it up to the size of a big presentation board. Okay, do we have any thoughts? Do we have any thoughts? Well, hopefully it makes sense to you that I say whatever the number of bouquets is, both 15 and 85 need to be divisible by that number, right? For us to have an equal number, which is exactly what they ask of us, to have an equal number of tulips in each bouquet, the number will have to be 15 will have to be divisible by this number, and 85 will have to be divisible by this number. Remember, I said when it comes to the highest common factor, lowest common multiple questions, they're not going to label it as such. You're going to have to understand that that is the mathematics which applies. So the greatest number which goes into both is 5, okay? Because it's 5 times 3 and it's 5 times 17. You don't have to check if those sort of factorize any further because all 4 numbers I just listed, including 5 twice, are prime. so they cannot be split any further. So here, yeah, it's the lowest common, the highest common factor, which is going to apply here. We can make 5 bouquets, and they will each have 3 white tulips and 17 red. I wanted to throw in an estimation question. It's questionable how sort of estimatey they are, because one of these will be the exact answer as far as the appropriate estimation method goes, right? I'm not going to spend time telling you what the obvious things to round these are. Too hard. So we'll round that first number to a 4. We'll round that second term to 1,600, and we'll round 15.7 to 16 as well. So notice immediately you can sort of simplify this, the 1,600 over 16. You'll just get 100. And 100 times 4 is pretty manageable. Okay, you will at the end have to know that the square root of 400 is 20. But that's manageable here. Okay, I wanted to include at least one of the estimation questions. Okay, they're frequently not that difficult, but I want you to know what they look like. This is the question I was thinking of earlier, where it's actually much, much more important to know what the word integer means. Okay? If you don't, you're not going to be able to tell which sort of outgoing x value is an integer or not. This is an example of a question where you can sort of solve all of the equations at the same time. What do I mean by that? If I wrote 4 to the power of x minus 3 equals 1, or if I wrote 4 to the power of x minus 3 equals 13, the first step to solve both of those equations is going to be adding 3 to both sides. So why don't we just do that for all our answers at once, not waste time doing it one at a time. You've only got so much time to waste. So as we go down, 1 plus 3 is 4. That's definitely a power of 4. 10 plus 3 is 10. You don't even need to continue with the rest. Yes, 13 plus 3 is 16, which is a multiple of 4. 61 plus 3 is 64, which is a power of 4. And if you know that 256 is a power of 4, I am really impressed. But ultimately, as soon as you get to B and you realize that 10 isn't, you've got your answer, move on. Okay, but this is an example where you can sort of not only check the answers rather than trying to solve some algebra, but you can do them all at once because the technique to do them is all going to be the same for all of them. So another one I've thrown in to highlight the possibility of a shortcut. So let me give you the time to make your observations. One thing you should definitely notice when you're making your observations is that those two equations are basically the same. And no basically, except for the fact that you've swapped the A and B, right? So you can think, how might two equations which look exactly the same possibly have different answers? Or values of A, values of B, etc. Any ideas? Especially because it says A does not equal B. So it's not going to be the same answer twice, and then ultimately you just need to double a number. My suggestion, by way of a hint, is you don't need to expand the brackets, you don't need to start solving everything. How could you make the terms as they are? You know, whatever A is times whatever is 2 more than A. Come up to 24 naturally. Any ideas?
If you multiply two negative numbers, it will become a positive number.
Good, that is the first step. That's you getting on the ladder. How's that idea going to take us to a shortcut answer? Anyone else want to help them out? What if the left-hand one was 4 times 6? And the right-hand one was minus 4 times minus 6? Again, I'm just thinking in terms of the brackets, right? So, for example, if you make A 4, then A is 4, and A plus 2 is 6. 4 times 6 is 24. Lovely stuff. But we can't just do the same with B because A doesn't equal B. But if I try to then just make it minus 4, okay, we get minus 4, but then minus 4 plus 2 is minus 2. We're not going to get 24 again. But actually, what if B is minus 6? Then B plus 2 will be minus 4, and we get what we want. Okay, so they will put these little tricks in there that essentially they are the same pair of numbers, but one pair has a minus sign on. One pair has a minus sign on. So here we can see that A is 4 and B is minus 6. So if we add them together, the answer is B minus 2. Let me also highlight, okay, what if you didn't notice this? What if you're not that mathematically inclined? You still only have to solve one of these equations, right? You're going to go through and you'll do the proper math student method of expanding the brackets on the right-hand side, getting A squared plus 2A, taking off the 24 on both sides and seeing how you can factorize it. You don't need to do the same thing for the second one. You're going to get the same pair of solutions, which will be plus 4 and minus 6. You're not going to get different answers just because one is an A and one is a B. So even then, even if you don't see that shortcut, if you're conscious of what you're doing, you can still cut down your calculation time. Okay. This is the question which scared me on your behalf and made me include that introduction section, including the standard deviation. So the table shows the number of packages shipped daily by each of 5 companies during a 4-day period. For which of the companies is the standard deviation the greatest? Can anyone remember or has written down those steps for how we find the standard deviation?
First, we calculate the average.
Yep, absolutely. First thing we're going to do, and this is the part where I'm hoping you don't need too much guidance. For each of those rows, we just add them together and divide by 4. This gets us here. So all I've done is exactly that. And by all I've done, you can tell this was the book, right? So we've got a mean for each category. And then notice in this right-hand side, we've just got a list of numbers. Some of them have positive signs, some of them have negative signs. Just flicking back so you can see what those are referencing. Company A, Monday. That's 5 below the mean. The mean's 50. That value is 45. For Tuesday, it's positive 5 because it's 5 above, right? But also notice that I said in the introduction, in practical terms, this is where you can stop. Because I've got a list which involves sort of 2 non-zero numbers and they're all fairly small for company A. There's an obvious winner, okay? Hopefully you now understand what I mean about why we need to square the differences from the mean, because if I just add together all the values for company B, I would get 0, and that's misrepresented. However, in a practical standpoint, you know that all of those numbers are the furthest from 0. It's going to be that one. You don't need to continue on with the tedious calculation. Even some of the older students I teach now have fancy calculators which do all this for them. So even in a calculator exam, you don't need to calculate this in the traditional way. Here you can just stop here. As soon as you get to this list and you go, that row has the list of bigger numbers, realistically that's enough. Okay. List S consists of 10 consecutive odd integers. Again, you need to know what those terms mean. A list T consists of 5 consecutive even integers. If the least integer in S is 7 more than the least integer in T, how much greater is the average of the integers in S than the integers in T? I would also like to use this question as an exemplar of, okay, we've been given a ton of information. What's going to be a wise thing to make our variables? And what's going to be a good way to proceed from here? When choosing what to make your variables, please choose whatever you are given the most information about. Okay, so for example, I could define list S from the biggest term and then just make it S minus 2, S minus 4, etc. I could even do it from the central term if, it was an odd number. And then sort of go S minus 2, S plus 2, and out like this. The reason, apart from the fact that it's the way most people would do it anyway, the reason I'm going to make my variable the smallest of the list is because the second sentence will then be nice and easy to put into algebra. If we're starting with that least integer, firstly, it is again the most natural way to list S and T, but when you take that second sentence, you'll be able to put that algebraically very simply and very quickly. So, solving it will look like this. We have a list. I've used my set theory brackets because I've studied math for too long, but you don't need to do that. Okay, I have just turned what they have given me in those first 2 sentences into algebra. and that t plus 7 equals s is that last sentence there. From here, just average in the way you would normally average things, and don't worry about the fact that this is algebra. It will work. So you can take the average of both, they both simplify nicely, and this will happen a ton with these consecutive integers, consecutive even number questions. To be honest, they quite like them. But it's because at the end of this, you can just simplify the average. You don't get an annoying expression. The terms you want to cancel out do, and they simplify. It's only once we've found the average of both of our lists, am I going to use that last equation, t plus 7 equals s. I replace s in my first equation, just sort of simplify. Okay, s plus 9 we can't really compare, but with t plus 16 we can. And then you just, look at the difference between them. So the answer here will be 12. It's not that a shortcut is really available, at least not as far as I'm aware. But it's a good one to highlight how you should go about methods which would not immediately seem apparent. This, however, is one where a shortcut is available, even if you just have a good understanding of what these terms mean. No pun intended. So, which of the following statements must be true about the average and the median, again, of 5 consecutive integers? They love these questions. Any ideas? Well, it's sort of hard to get going if you feel like they're not giving me the list of integers, so I can't just put pen to paper and start calculating. But if you have a strong idea of what each of these mean. For example, 2 is the easiest one for me to say yes immediately. It's just the definition of a median. The median itself must appear in the list. Not necessarily true in general for the average or the mean. In this case, though, it will be. Because you think if you've got a list of 5 numbers, one next to each other, these external ones are going to be equal distance away from that central one. These inner 2 also equal distance away from that central one. And that central one will itself be the mean. Hopefully you can also understand that it will be the median as well. Again, you just list the numbers in order. The middle one is your median. So actually all 3 of these apply, but it's not because of a specific application. It's not because of a specific formula, etc. It's because of abstract reasoning and understanding well what these terms mean. By the way, if you don't, you can still do this question very similarly to the last one. You make x your first integer, and then the next one is x plus 1, the next one is x plus 2, the next one is x plus 3, etc. When you do the average of those, you'll get 5x plus 15 all over 5, and x plus 3 will indeed be one of your integers. And hopefully at that point, you'll also realize it's the median as well. Okay, so it's not just you have to have really impressive mathematical insight, otherwise you're in trouble. No, it just really helps. You got two left. Two left. And I didn't want to put the worst question as the last one, because I want us to go home with some level of happiness in our souls. However, when I saw this question, I knew I had to at least give you a fighting chance. By the way, this is the only question where, frankly, I'm not even going to ask if any of you have any idea. If you do, I have some classes you can teach on Mondays, Tuesdays, and Thursdays. Okay, this is exactly the sort of question which made me think, oh, actually, some of these questions are way more like a mathematics competition than they are a general entry exam. Frankly, reading through the book, there are a few questions which made me throw my arms up in the air and go, is that strictly necessary? So, if you get a question like this or a question similar to this, do you remember at the beginning I said we're only going to highlight one or two things about sequences and series? This is really it. With a question like this, there are two observations which might help you. And that will be one, if the sequence is strictly increasing, i.e. each term is getting bigger as we're going to the side. Or in this case, every term is strictly decreasing. We are only getting smaller as we go to the right. This gives us the opportunity for a mathematical trick that I'm aware of, but only because it was relied upon in my second year at university, right? So it does not seem fair. Because we're strictly decreasing, we can create something called an upper limit. The biggest it can possibly be. Because even without, you know, calculating 1 over a quarter plus 1 over a ninth, because we can see that 1 over 3 squared is smaller than 1 over 2 squared, it's definitely going to be smaller than if we just had two of those terms, right? The right-hand term will be slightly smaller. And then we can simplify that slightly. Okay, those first two terms are less than a half. Once you've got that general idea, the second slightly more complicated half might make a bit of sense to you. All of those remaining terms are less than, or indeed, of course, equal to, in the case of 1 over 4 squared itself, they are all less than 1 over 4 squared. So those 7 terms together will be less than if we had 7 of that term on its own. It's the same trick, right? So the first, ignoring the 1 for a moment, the first 2 terms are less than a half. The remaining terms are less than 7 over 16. And if you remember the 1 again, you can go, cool. In that case, our whole sum S is less than 1 plus a half plus 7 over 16. Okay, so that's going to be 1 and 15/16, which is itself less than 2. This is the moment I will remind you that I picked this because it's bad. Okay, though, yeah, lots of the other questions are bad, but this is the worst I could find. Okay. If you see something like this on the exam, let's just scroll back to the sort of full screen version. If the terms are strictly decreasing like they are here, you are going to be able to use this technique to find an upper limit. If the terms are strictly increasing, you'll be able to use a similar technique to find a lower limit. But don't back your head over it. Worst comes to worst, it comes up and you go, oh, even though, you know, it was mentioned in this presentation, I can't really remember. That's fine. Move on. You've got a lot of questions. It's not going to be make or break time. I just want to give you the best chance I And let's end. Oh no, oh, we've got a few left. Sorry, apologies. Okay. Here we've got one of those work problems, okay? It's not for art and Vita or whatever it was before, but it's the same method whether it's a pipe or a person. So, anyone got any guidance, suggestions, recommendations? How should we get started here?
First, calculate how much time does one plant to fill the tank completely.
Right idea, but we're sort of going to do it the other way around. So you could do it like that. You could work out how long it's going to take to fill the tank completely. But after you've done that, you will have to invert it to think about what's the work it's doing per hour. So for that reason, you can kind of just skip that first step. So for example, okay, got this typed out as well. So that's going to tell you that the first pipe will be able to fill up to 1/6 of the capacity in a single hour, okay, because it fills a half in 3. For very similar reasons, that second pipe will fill a 1/9 capacity within an hour. For these sorts of questions, you always need to be thinking per unit time. But after that, it's not so bad. We just have to do a 6 plus a 9 and carefully invert our answer at the end. But apart from this, it's really just like the example one or one of the example ones which I showed you in that prior section. Okay. It's another one that I included to highlight the importance and to demonstrate how we can sort of algebraify correctly. When n liters of fuel were added to a tank that was already 1/3 full, the tank became 7/9 full. In terms of n, what is the capacity of the tank? So, even though none of these answers are specifically like, 5, 7, they are in terms of n. They all contain this number of liters. We still need to create an equation to find these values in the first place. And here I want you to be thinking in terms of amounts of fuel. So originally we had 1/3 times whatever the unknown capacity of the fuel tank is. The amount added is just n. We don't need to turn that into a broader expression, just n. Cool. And the total amount will then turn to be 7/9 times c. For example, if you are given a proportion of the tank which is full, for that to be useful, 99 times out of 100, you're going to have to be multiplying by the capacity of the tank. To turn it into a quantity, in this case an amount of fuel, which is comparable across several instances. And by the way, this sort of presentation is not something I just do when I'm doing a presentation. Going from 0 to 100, reading the question and writing down a perfect equation first time, it's not going to happen, to be honest with you. break it down. Okay, what's the original amount? Because if I take the original amount and then I take the added amount, then that should give me the new total amount. And once you break it down like this, writing this equation 1/3 c plus n equals 7/9 c is something you can break down. I took the original amount, 1/3 c, I added some new amount, n, and I got my total amount, 7/9 c. It's a much nicer way to break it down. Hopefully you are wiser than my school students, because I recommend this all the time and they all think I'm speaking to someone else, but truly this helps. But as highlighted, it's the sort of algebraification that's important here. Actually solving the equation once you've got it is not too bad. You can see it on the screen in front of you, but I don't think it's useful for me to take us step by step from here. Cool. So, do you remember at the beginning I mentioned functions and then said they're not really important, but sometimes you will need to understand the language the question is being given in. This is the language of functions. They give you the definition of a function, but if you're not familiar with functions, there's a good chance you might not know what to do with it anyway. Notice they specifically say that x is positive. But then they say if u equals f of t for some positive numbers t and u, what's t in terms of u? If you don't know that u equals f of t is an equation in disguise, you're not going to be able to get started from it. You're just sort of going to look at this and go, okay, what's next? When they tell you something like this f of t means if you put t into this function, i.e. the square root of t minus 10, the answer is u. So you get this equation here. That's your starting equation. And to be honest, knowing that that is the starting equation is about 50% of the difficulty. Because the two-step rearrangement to get t equals something, not that bad. Okay, what you need to know here is what information the question is giving to you. And of course, invert carefully, just like I mentioned before. If you're looking at that difference between the second step and the third, when you square both sides, square all of it. Okay, not just u squared plus 10 squared. You put those in what we call invisible brackets and you be nice and careful. Okay. I wanted to include one digit question, but good news, it also highlights why I did not include more. They're not so bad. You just need to know sort of how we can use this idea of digits as a method within itself. The positive two-digit integers x and y have the same digits but in reverse order. Which of the following must be a factor of x plus y? What you need to know here is the starting point. Just like we can break down 215 into 2 times 100, 1 times 10, and 5 times 1, we can do this algebraically as well. So in this case, x would be the number ab, which is 10 times a plus b. And for y, we've swapped them. So it's 10 times b plus a. Once you've got those equations on paper, adding them together and seeing that the answer is divisible by 11 is not so bad. But again, it's making sure you get those equations on paper to begin with. Okay. Oh, by the way, now we've looked through a couple of questions. Hopefully you can see. If you're going to remember any of those terms from the intro slide, please make it the word integer. They use it all the time. Which of the following expressions can be written as an integer? These sorts of questions are just going to be rewriting and mild manipulation. Okay, it's a bit more difficult to be sure that something can't be written as an integer, but I would suggest the very informal method of try for a little bit. If you can't, it probably can't be done, right? That's not exactly a very solid mathematical method, but you have 1.5 minutes per question, so these things have to be considered. So, can you see any of these which can be written as an integer fairly quickly? Again, if you can limit down which options you need to look at, that's just going to make your life a bit easier. And notice, actually, kind of just like when we spoke about the language skills section, the logical reasoning section, you don't even need to consider whether 2 and 3 are both correct, because it's not even an answer option. So maybe, for example, if you go, oh no, oh look at that, 3 can be written as an integer, then you know it's it's C or E, and that's it. And that only depends on whether 1 can be written as well. Any ideas? Can anyone see any of these which can be written as a whole number if we remove the technical language of an integer? Which of these can be written as a whole number?
The third one.
Yeah, the third one for sure. I definitely picked that as a highlightable answer because, yeah, the square root of 82 times the square root of 82 is 82. That's what the square root means. And frankly, we don't even care that they have it over 82. 82 is already an integer. Okay, we can divide it by 82 and get a different integer, i.e. 1. But as soon as you realize that those square root signs can go away, that's really enough. Anybody have any idea with either of the others? One of the things that simplifies this for me is that there is stuff all you can do with number 2, right? There's nothing too simplified. It's one number times another. Can you rewrite that? No, not really. No square roots are cancelling out nicely. So even if you so you can probably make an educated guess that no, that one can't be written as an integer. The only one that really needs to be highlighted is, yes, we can write the square root of 82 plus the square root of 82, but no one writes x plus x in equations, do they? They write 2x. And once you write this as 2 times the square root of 82, actually dealing with the squared is nice and simple, like I highlighted in that order preserving slide. You square the first number to give 4, you square the square root of 82 to give 82. Notice I didn't even put an equals. It does not matter what 4 times 82 is. As soon as you know it's a whole number, move on. All right? It does not matter what the answer is. What matters is that it's a whole number. Cool. This one I'm not lying. Really is the last one. This is my last example of algebraification. Because actually, this is not a question which involves making an equation. It involves representing the necessary terms within the letters that are given to you so that you can express the number of boxes that remain to be filled algebraically, regardless of the fact that it does not actually come from an equation. A total of S oranges are to be packed in boxes that will hold R oranges each, with no oranges left over. If I'm reading that, okay, I know it's all online now, whatever. With no oranges left over, I am underlining, and I'm underlining it at least once. Do not think that information is unimportant. If they give it to you, it's important. When n of these boxes have been completely filled, what is the number of boxes that remain to be filled? The key insight here is to realize that that first sentence gives you enough information to define the number of boxes total in terms of S and R. If there are S total boxes, and there are which hold R oranges each, and again, crucially, there are no oranges left over, the number of boxes will be S over R, the number of oranges divided by the capacity of the boxes which hold them. That will give you the number of boxes. We would need a further part of the equation, you know, maybe to account for unfilled boxes or unboxed oranges, except for that last part of the sentence, with no oranges left over. And again, I'm following the advice that I gave you on a previous slide. I've made an equation which isn't with variables. The ones still left to be filled are the total number. Okay. N should be the number filled. But at this point of typing the presentation, I was tired already. So it'd just be the total number, take away the number which has already been filled. So S over R is the total number. I didn't need to write something for the number which have been filled because it's simply a letter which is given to you. But even once you recognize that S over R is the total number of boxes, the rest of this is unnecessary, right? Because E is the only one that contains S over R. But, you know, if you get as far as the S over R part, you're probably not going to struggle with taking N away afterwards. Okay. As promised this time, I was not lying to you. Before we sort of end it there for today, next week we're going to be looking at the data insights part of the course, including the data sufficiency section. As has been the case with the last couple of talks, okay, don't get me wrong, we're not a ton of time off, but I'm not expecting it to take the full 3 hours. Okay, everything here is scheduled for 3 hours, but I think honestly only the language section of the course really requires it. I say that as mere motivation. There's only one left. Hope you guys all have a great evening. Thank you for coming down. Though before we go, does anyone have any questions? No? Cool, I'll take that as a sign. I've been nice and informative. For the online attendees as well, the option for questions is there for you as well. Please unmute yourself if you have anything to ask. Okay, in that case, thank you very much, and I'll see you for the last section next week.